Okay, Tim. In the last session, we are discussing about class level typecasting. I think we have completed primitive data typecasting and the user-defined data typecasting in Java, which was classified into two types: upcasting and the downcasting. So upcasting part is completed. Now we'll start to understand about the downcasting. Okay. Downcasting. So before even understanding about downcasting, we have to understand about an operator. The name of the operator is something like the instance of operator. Instance of. Okay. So you will come across this operator very often when you are developing real-time applications. So let us understand this with a simple example. Let us say that I have three classes. I have class A and I have class B. I have class C. Okay, I have three classes and I want to make a relationship between these classes. Let me say that the relationship is like the class E is extends to B and the class B is extending to A, right? So I have created a relationship between these classes and this is called as the multi-level inheritance, right? And I also want to take a main method. Okay, so let us say this is my main method, public static void. Okay, we do not have any problem with this code, but let us assume that I have a requirement. The requirement is like, I can create many number of objects depending upon the requirement. For example, if I have to create an object for class C, I can create an object like this, C1 equal to mu C, right? So the object creation is not limited. So I am allowed to create any number of objects if memory consumption is not the actual requirement. If I'm not worrying about the memory consumption, I can create n number of objects. As a developer, I am allowed to create n number of objects. So not considering the performance, I can create n number of objects. And also for the class B, when I say class B, even I have an option to create n number of objects for the class B also. Okay, so let me say I am creating something like 4 objects for the class B. Right? So object creations, there are 8 objects created, right? And if you look at the reference variables, so reference variables are like C1, C2, C3, C4, B1, B2, B3, B4. So these are my reference variables. Okay? So C1, C2, C3, C4, right? B1, B2, B3, B4. So this is the reference variables that I have. The idea here is, okay, without see, just by looking at the reference variables, okay, if I just ask you, B1 is a reference variable, okay? If I just ask you what is the type of the B1, or else, this is a reference variable belongs to which class? By looking at this, we can say, by looking at this, I can say that B1 is a reference variable for the type B class. Right? Likewise, when I ask you something like, when I ask you something like C1, okay, what is the type of C1? Okay, so we as a human beings are able to guess the type, right? We can just visualize it. Okay, C1 is of what type? C1 is a reference variable of class C type. I can say that C class type. Okay, likewise, when I ask you about the reference variable of the type of C3, C3 is a reference variable of C class type. So by looking at this, we can say at times, okay, we are going to use these reference variables in different parts of the Java code, right? In different parts of Java files, or in different parts of Java, within the same method in different lines. Right? Sometimes we used to get these reference variables in the runtime. In the runtime, we have to deal with these kinds of reference variables, right? When you are looking at that, when you are dealing, when you are looking at such situations, or when you are dealing with such situations, you won't be having an option to look at this code. Okay? Just by taking the reference variable, you have to find what type of class this reference variable is referring to. In the runtime, you have to find it what type of class this reference variable is referring to. You need to do such kind of guesses. Okay, by looking at this, we can say, but you have to guess it without looking at this, without even checking each and every line of code, how the object is created and what type this reference variable is referring to. If you get such situations without looking at the code, if you want to guess, or if you want to come to a conclusion that okay, C1 is referring to the C type, B1 is referring to the B class type, right? So there you will be using what? You will be using the instance of operator. Okay, let me keep it simple. If I just have to print this, okay, if I say system dot out dot println, okay, I want to ask, okay, C3 instance of. If C3 is instance of C, if it is an instance of C, right, it will return true. Means now we can have a conclusion that okay, the C3 is a reference variable of the class C type. Now we have such conclusion. Likewise, okay, somewhere in the somewhere in the code, if we ever want to ask if B1 is instance of B, right? B1 is what? B1 is definitely B1 is part of what? B1 is a reference variable referring to the B type. So you are suppose you will be getting true. You will be getting true. Likewise, if I just ask you something like B1 is instance of C. Okay, B1 is of what type? B1 is basically referring to the B class type. But what I am trying to do, I am trying to check if B1 is instance of C. No, it is not. B1 belongs to B. So I am trying to check it for C. I will be getting a runtime error. Okay, first, let us try to understand this basic theme with a simple Java code. Okay, let me write this code for you. I want to take a simple class, simple 3 classes. Okay, let me remove all this. Let us say I have a class A, I have a class B, I have a driver class. Let me remove all this, not required. Okay, so what I want to do, I want to create objects. I want to create a few objects for class A. A1 equal to new A. Okay, A2 equal to again new A. A3 equal to new. 3 objects has been created. Okay, and likewise, same thing I'm doing it for class B. B, B, B. Okay, this is going to be B1. So these reference variables can be anything. Okay, you have to ensure that a meaningful name is given. That's it. B. So totally how many objects are created? Totally I have created 6 objects. Right? How many classes I have? I have two concrete classes and one concrete public class. So what I want to check, okay, system dot out dot println. I just want to check if B1 is instance of is an operator. Okay, instance of Java, it's a keyword, it's an operator. Okay, this is going to perform an operation, a kind of checking whether the reference variable is belonging to the particular class type. I'm checking if B1 is belonging to B type. What should be the answer? B1 is part of C, part of B. Definitely I should get an output like 2 should be displayed on the console. Yes or no? So can we check that? Okay. Let me open the comment prompt. Okay, one parenthesis is missing. Java space. Okay, true. It says true. Yeah, just I want to check again. I want to check if if A1, something like if A1 is instance of A. So A1 is a reference variable of what type? It is of A type itself. I just want to confirm. In the real-time applications, you don't do this confirmation in the same, the same line. Okay, so there will be some situation where you will be receiving only the reference variables. You will be receiving only the reference variables. For example, okay, let us say that if something like void, there is a method called void m1 method inside the class A. System dot out dot println. Okay, so I just want to print something like m1 method of class A. So this m1 method is part of class A, okay, and I am taking another method. Okay, okay, let me name this m1 method as m1 itself. This m1 method is part of class B. Okay, both methods names are m1, but the business logic is something different. Okay, the logic is something different inside. Okay, what I want to do in the runtime, okay, I will be supplied with the objects like a1, a2, a3, or something like b1, b2, b3. I will be given only the reference variables. Okay, my intention is if I receive the if I want to check the condition. Okay, if the reference variable belongs to a, I want to execute m1 method of a. The reference variable belongs to b, I want to execute the m1 method of b. How I can do this? Simply I can place an if condition. Okay, inside this if condition, I will be using this instance of operator. Let us say that my requirement is, okay, if reference variable belongs to a type, okay, execute m1 method of a. So this is my question. This is my requirement. Okay, if the reference variable belongs to a, you want to do what? What do you want to do? You want to execute the m1 method. Okay. So let us say that I am taking the a1 reference variable and I am checking if a1 belongs to class. If this is returning true, definitely the control will be traversed inside the if block. Inside the if block, what I will be doing? Simply I will be saying that a1 dot m1. Simply I will be saying what? a1 dot m1. Right? So m1 method of a gets executed. Okay, let me try this. M1 method of class A. So in the runtime, if I get a reference variable something like, okay, I'm checking if a1 is instance of b. Definitely I will be getting error because a1 is not instance of b, right? A1 is instance of a, but I'm checking whether it is instance of b. It says incomplete, some kind of error we are getting. We will understand why we are getting this error. Okay, if it is valid, if it is if the reference variable is actually the referring to the actual class type, you get true. If not, you get this kind of error. Right? For example, if I say b1 instance of b1 is referring to b, this is going to return true. Okay, so if this is returning true, I want to execute the m1 method of b. I'm using this reference variable. I am just invoking the m1 method, which is of b. Okay, so if you see the output is going to be java c space driver.java and java method one of class b. Right? So instance of, now we have got some understanding about the instance of operator. Okay, now what I want to do, I want to do the same thing by using what? By using the extends key. Now this is where our understanding should be very much high from here. Okay, what I am trying to do here is, okay, let me remove this method, m1 method. Let me remove this method as well. I am taking another class here. I am taking C class. I have 3 classes. Okay. Now I am making a relationship. My class C is extending to B. Okay, my class B is extending to what? My class B is extending to A. My class A is, okay, I'm not extending anything. Okay, I have C class extends to B. I have B class extends to A. Right, let me remove all this. Okay, let me keep this, no issues. I have 3 objects and I let me create 3 more objects for class. You see, EC2 equal to 3 3 equal to, okay, I have supplied with how many objects are created. Totally 9 objects are created, so I have 9 reference variables. Okay, and each and every class is somehow related to another class. Okay, so class C is extending to B, relation is there. Class B is extending to A, relation is there. If we want to represent this as an hierarchy, okay, how I can represent this? So this is how represent. This is how the high level diagram is going to be. Okay, now if we ever had to draw, okay, it is going to be like this. So why I have taken 4 circles? So now this is my class here. This is my class B. Oh, sorry. My class C. This is my class B. Okay, and this is my class A. Okay, and this is my object class. Parent super class for the class. If you are not extending to any other class, that is going to extend to object class. You know this, right? Since A is not extending to any objects, any class, it is going to be extended to object class. Compiler will add this, right? Compiler is going to add this. Now see, interesting will happen. Yes, so there is a relationship, you know. B is C is extending to B is extending to A is extending to object. There is the solid relationship. Okay, so this is the child. Okay, this is going to be the parent. Okay, this is going to be the great grandparent. I mean, grandparent class, and this is going to be the great grandparent. Right? So because of this extends keyword, the relationship is. Now what I want to do, I have created many number of objects, right? If you see, this is how the objects are created. Okay. So these many objects are totally, I have created 9 objects. I have reference variables like A1, A2, A3, B1, B2. Right? So I can check, right? I can check if let us come from here. Okay, I want to check if C1 is instance of. Okay? So this is the instance of operator. The instance of operator. So this is talking about the operator. This is talking about what? This is talking about the operator, instance of operator. Okay, this is saying C1 is saying the reference variable of an object. Okay, and this one says the type, class type, or else I can simply say type. What I am doing, I am checking if reference variable is of A type. This is the question. Okay, C1 is where? This is the C1, right? C1 is of C type. C1 is of what type? C1 is of C type. I am checking if it is of A type. Okay, now what will happen? Okay, what will happen? Okay, so C1 is of what type? C type. If I am using the instance of operator, saying that C1 instance of C, C1 instance of C, if I say, definitely is going to be valid. Right? But I am saying C1 is instance of A. Right? If you just let me execute this code. From dot out dot println. Okay, I am trying to say C1 instance of. Okay. Let us see the output. Now you are not getting any error. See, previously you got error because we haven't created any relationship between the classes. Okay. Now there is a relationship. There is a multi-level inheritance relationship. Okay? Now you are getting true in the console. Output is you are getting true in the console. Why you true in the console? Now look at the checking hierarchy. Okay. You are checking C1 instance of here. Means C1 is of type A or not. You are checking. The question is C1 is of type A or not. C1 is of type A or not. This is the question. Okay, the control will be checking like Firstly, C1 is actually of C type. C1 is actually of C type, but you want to check for A type. No issue. So it will, since there is a relationship, it will go to the parent and see. C1 is of B type. No, it is not. It will go to the parent and see. C1 is of A type. Matching, right? So C1 is child of, C1 is of C type, which is child class, but due to the inheritance relationship, right? Due to the relationship, okay, still it is going to be returning true. Why? Because if you see the parent of C, B is the parent of C. If you see, A is the grandparent of C. There is a relationship, right? So that's why the type is matching it. That's why in the output you are getting true. So it is going in this direction, right? So let us see one more example. Okay, I want to check something like, let me do this. B1 instance of, if I say B1 instance of B, straightforward answer, the output is going to be 2. Or no? If I say B1 is of B, straightforward answer is what? B1 of B type 1. B1 instance of B means B1 is of, are we checking B1? So output is going to be blindly true. Going to be what? True in the console. Okay, what I want to do, okay, I want to check if B1 is instance of B1 is instance of B. I want to check this. Okay. B1 is instance of B, right? So B1 is actually belongs to B type. I want to check if it is instance of B. No worries. We'll go to the parent and see. Yes, valid. According to the inheritance, okay, you can either use it, you can either say B1 is of B type or B1 is also of A type or B1 is also of object type. You can go in this direction. So in the through this direction it is going to be valid. You will get the output as true only. Valid direction. Okay, one more example. Let me say something like, okay, C3 instance of object. So you are checking whether the C3, okay, this is what you are trying to check. C3. Okay, the actual type of C3 is, it's a C type only, right? C3 belongs to class C, right? C3 belongs to class C, but you are checking it for whether it is belonging to object or not. You're checking if the type is object or not. Okay? So C, okay, it will go to the parent is B, go to the parent is C, it will go to the object, matching. If the child class is not matching, it will keep checking in the multi-level hierarchy whether if one of its parent is the given type or not. So that's the takeaway. Whether the one of the parent is the mentioned type of. Okay, let me execute this. Okay. I want to check G1 is of object. Yes. You are getting true. I want to check if B1 is of object. If B1 is here, right, B1 is of actual type is B, but if you look at the hierarchy, right, the parent is A, grandparent is object. Definitely you will be getting true only. Let me execute this. True. Okay, now I want to do some changes. What I want to do is, my question is, now it is going to be, okay, if B1 is instance of B1 is instance of C. Let me paste this here. B1 is instance of. I want to check whether the B1 is instance of C or not. Okay. Actually, what is the type of B1? What is the actual type of B1? B1 is referring to what type? B1 is referring to the class B type. B1 is actual type is class B type. Right? It is going to return true. Okay, if you are trying to do the checks for the immediate parent or immediate great parent. What do I mean? Okay. You can check if the B1 is instance of B, B1 is instance of A, the B1 is instance of object. This is going to return true only. If B1 is instance of B, it is going to return true. A, it is going to return true. going to, if it is object, it's going to return true. The direction should always be like, okay, it should start from the actual class, and you can climb up the hierarchy, you can climb up the levels. B1, it is going to return true. If you check B1 is instance of A, it is going to return true. If you check B1 instance of A, it is going to return. But you cannot check B1 is instance of C. You cannot go to the opposite direction. You cannot come down to the level. Even though this is the child, okay, but you know, it is not accepted. I can climb up the ladder, but not the opposite. You cannot do the inverse things. Inverse actions are not possible. That is not accepted. Right? So ideally it should return false because it is going in the opposite direction. According to the inheritance hierarchy, it is going in the opposite direction. So let me do this. This is the code. B1 is instance of C. This is a basic understanding, but the real-time utilization, okay, will be understood soon. Okay, you get true, and false. Likewise, when I say something like, okay, A1 is instance of A1 is instance of the question. Okay, A1 is of what type? First, trying to find the actual type. A1 actual type is, okay, this is the actual type, which is A itself. Right? A1 actual type is A itself. Okay. Firstly, it will try to map to its actual type, which is what? Which is A itself. Actual type. From here, you are checking whether it is instance of B. Instance of B. So it will go in the opposite direction. It is going towards the children direction. When it's going towards the opposite direction, definitely the output is going to return false. Direction is not valid. Where is the proof? Let me execute this. Java C space driver.java. So true, false. Right? Okay. I hope you have got some idea about the usage of instance of operator. You are trying to check whether they belongs to the actual type that is valid. If not, they belongs to the immediate parent type or the grandparent type. Okay, so it returns true, but so with the help of that return type, okay, it may return true or it may return false. It depends upon the type that you are passing. But so with the help of this true and false, we can do a lot of operations that we are going to discuss step by step. But this is the actual idea about the instance of operator. Okay. Let me take a small real-time example, something like, okay, I want to take a meaningful example. Okay, instead of taking this class A, class B, I will take something like I have an animal class. So I have dog class and I have cat class. Okay, totally I have three classes. I have 3 classes: animal class, dog class, and the cat class. Okay. My cat is extending to the cat class is extending to animal. Okay, this dog class is also extending to animal. We will just try to represent this with the diagrammatical form. Okay, these are our classes, isn't it? Yeah, 3 classes. Okay. So in the top you have animal class. Okay, and the dog is also extending to animal, and you have the cat class which is also extending to. Right, so this is how the representation is going to be. Okay, and there is an inheritance relationship, isn't it? Extends keyword you are using, so there is a relationship. Because of what? Because of the extends keyword. Okay. And again, this animal is extending to. You don't see this, you don't visualize these things, but the compiler is going to extend this to object class. Okay, this is representing the hierarchical inheritance. Okay, now what kind of instance of operators I can use here? I can either say, if I say animal, or else let me say top D equal to new top. So I can check. Okay, let me go back to the code. I can simply say dog b equal to new dog. Okay. Cat c equal to new cat. So what I want to do, I want to choose system dot println. I can ask, okay, if the dog, the d reference variable is instance of animal. Animal is the parent. Or else I can also ask if c reference variable is instance of parent. Right? By looking at this diagram, okay, I'm asking whether the d reference variable is instance of parent. First, it will check for the d is instance of dog, right? But I'm asking whether it is instance of animal. Okay? So then it will go to the immediate parent is animal itself. So this is going to be valid. So both cases it is going to return true one. So d reference variable, the c reference variable, the instances are being checked for the parent class. It is going to return true one. Right? Got this. Should not be any spaces. Huh? Okay, it is going to return. Okay. Now what I want to do, I want to do the upcasting here. I want to perform what? I want to perform the upcasting here. My upcasting is like, I would be saying animal A1 equal to new dog, animal A2 equal to new cat. Animal A1 equal to new dog, animal A2 equal to new cat. Right? So I am taking three methods. Okay, now this part we must focus. Okay, the name of the first method is something like now let me take the method like void heat method. Okay, system dot out dot println. Okay, every animal eats. Okay, here I am taking a method like void sound method. The dog is over void a sound method that says non. Okay, let us imagine that in the runtime we are getting the reference variables a1, a2, and also I can add these things like this. I have reference variables like a3, no, a4, a5, and a6. Okay, these are the reference variables that I have. These are the actual reference variables that I have. So let me take the method of the that's are fine. Okay, now what I want to do, I am using the if condition. In the runtime, if someone is passing, like if someone is asking me to check, okay, I will be getting the reference variable as a1. So if I check if a1 is instance of what, a1 is instance of dog. If a1 is instance of what, instance of dog, I am checking. Okay, now focus here. I am using the concept of upcasting. We have discussed this in the previous class, upcasting concept. Okay, the child class reference is being placed to the parent class. In this case, you will not get any false here because the object is being created for the dog class, but the reference type is animal class. Okay, no matter even if you pass dog or if you pass animal, you will be getting true only. Here you have an option to pass dog as the check the dog as the type or check the animal as a type. You are checking what you are checking instance of, right? Instance of is being checked on the A1 reference variable, which is A1 reference variable, right? And A1 is of actual type is animal type. A1 type is actual, but the object is created for the dog. Object is being created for the dog, right? Okay, even if you pass dog here, you will get true. Even if you pass animal here, you will be getting true. Okay, let me understand. System dot out dot println. So in this case, since it is an upcasting concept, the reference variable A1 can be checked upon the instance of operator. Either for dog, it is going to return true only. Okay, either for animal. You may be thinking why it was returning false in the previous examples. In the previous examples, we have been done upcasting. Right? Okay? Directly, the type is also same. The object is created for the same type. But here you are doing what? You are doing a kind of what? You are doing a kind of upcasting. Type is different and the object is created for the different. You can pass in the runtime if someone is passing new dog, right? You can check whether it is of dog type or not. What I'm trying to do here is, okay, let me say. I'm saying A1 is instance of dog. I want to print system dot out dot println. Okay. It's a dog. Okay. Yes. It's a cat. Now see, I have passed. I am checking whether A1 is instance of dog or not. Okay. A1 is instance of dog only. Okay, the type is animal type, but since you are doing an upcasting, the object is created for the dog class. The runtime you are passing the dog object. This dog object is being mapped to the animal class type, or this dog object is assigned to the animal class type. In the runtime you are passing dog object, so you are checking the instance of it's a dog. If I just change it to, if I just pass something like A2. Okay. So A2 is of what type? Is of cat type. I am checking whether it is a dog or not. So this condition will fail and this condition will be satisfied. Now the output is going to be, the reference variable is going to be of cat. It's a cat. Let me run this. Okay, let us visualize this. Okay, by just writing down the code. Sometimes it will not make any sense. Let us visualize this. Imagine that this is my code. Imagine that this is my magical code. Okay, and you are allowed to pass. You are allowed to pass what? You are allowed to pass the. Okay, let me put it here. Right? Imagine that this is a machine. A machine. So this machine accepts some inputs. Some inputs like you can pass the object references. You can pass what? You can pass the object references. Okay. So let me remove. No. So what are the object references you have? You have some. You have what? You have A1, A2, A3. Likewise, you have A4, you have A5, you have A6. Okay. Totally 6 object references are there. Right? Now, if you pass the first reference, okay, assume that you're passing A1, passing this object reference to this machine. Just imagine that this is a machine. This is a program. This is a magical code. This is a magical. Now see the power of instance operator. Power of instance of operator. You are passing what? You are passing A1. Okay. And A1 will be like, A1 will be checked with the instance of operator. Okay, instance of operator, whether it is an instance of dog. Okay. Definitely A1 is what? A1 is instance of dog. Isn't it? Okay, this is going to return true. You are checking this runtime, the runtime. You have given the bunch of reference variables. You want to check whether this reference variable is belong to the dog type or the cat type, right? So this A1 is belonging to the dog. Definitely the if condition will be executed, right? So output is going to be it's a dog. Now you will get to know, okay, this a1 is a reference variable of what type, of the dog type. So new dog object. Okay, if you get access to these reference variables, you can call all the methods that belongs to the dog class, isn't it? Now you come to know, you can call, you can deal with the properties and the variables, properties and the behaviors of the dog class. Likewise, let us say instead of a1, okay, in the next time I'm passing what? I'm passing the reference variable like, no, a4. A4 will be checked whether if A4 is instance of dog or not. So where is A4? So this is the A4. Okay, but unfortunately, this A4 is instance of cat. A4 is instance of cat. Right? Now this if condition will be failed. If condition will be returning false. False means this if block will not get executed. Now the control will be traversed to the else block. Now we can say that it's a cat object. Now it is clearly saying that A4 is of what type, A4 is of what type, A4 is of cat type. Okay, assuming that you don't know, you don't see this code, assuming that you don't see this code, you have given only the reference variables. Okay, you have got access only to this reference variables a1, a2, a3, things like that. A1, A2, A3, A4, things like that. You have only access to reference variables, and you want to check, but you know this could be either the dog type or it could be either the type. You know this. You know this thing, you know the class names, but you don't know whether this a1 is belongs to which one belongs to the cat type and which reference value belongs to tab. If you encounter such situation, now in instance of operator will come into your rescue. You just use that with the simple code. You can just check the instance whether it belongs to the particular instance or not. Okay, by that you can confirm. After confirming, what you will do, just you want to print this or not? No, you can execute the logic behind this code. For example, if it is returning dog, if you get to know that, okay, this a1 is belonging to the dog class, you get to know that, if you get to know that information, then you have what? You have rights to execute this method, sound of this method. If you know that it is a cat class, you can execute this method. With the help of runtime reference variables, you can execute this method. That is the power of instance of operator. Right? Okay, to execute this method, okay, you have to use a separate concept called now the downcasting will come into the picture. Now casting will come into the picture. I have just said in the beginning of the class, to understand downcasting, we are supposed to understand the instance of operators or no. Downcasting, we are supposed to understand instance of operator. Now we have understood what is instance of operator. We are able to check whether the particular reference variable is belonging to the particular class type or not, or it belongs to the parent type or not. That is the first thing that we have discussed. Okay, what are the things that you have discussed? We have checked. We are able to check whether the particular reference variable belongs to the particular class type or its immediate parent type or its immediate parent. The first thing we have checked this. We have checked this by making a relationship, right? So I have taken many classes. I have taken class A. Okay, I have taken class B, which is extending to A. I have taken class C, which is extending to B. Right? What is the second thing I have done? We have also checked with the help of upcasting. How we can utilize the instance of operator with the help of upcasting? What you have done, you have taken the animal class and we have created the reference variable. We are checking whether this A is of dog type, or we have taken another animal class. Okay, whether this B is of what? B is of. Okay, so this is how the code looks like. Class, you have animal class, okay, and the class dog extends to animal. Okay, and the class cat is also extended to animal. This hierarchical relationship, okay, you have used the upcasting concept. Child object to the parent class type. Child object to the parent class type. Okay, and what are the reference variables? You have the reference variable A, have the reference variable B. The runtime, what you want to do, you want to check whether this A belongs to the cat type or dog type. Okay? Whether you are used what? You have used instance of operator by using if condition. Whether this B belongs to the cat type or dog type. Okay? We are able to do the confirmation. We are able to confirm whether it is confirm its type. Confirmation. Confirm whether it is belong to the particular type or not. Okay, how to execute the logic inside? How to execute? After confirmation, then what? Then what are the things that we need to do? After confirmation, then what are the things that we are expected to do? That part will be understood in the downcasting, which is in the tomorrow class. So now the downcasting will come to the picture. Right? So with the help of downcasting, okay, if you pass a particular cat object, okay, you can execute. It will just display meow meow. If you pass a dog object, it will just display wow wow wow. You have that control in the real time. You have that control. You have that power in the real time. Okay, first confirm which object, okay, which type it belongs to. To confirmation, we'll use instance of operator. After confirmation, okay, if it belongs to dog, it definitely belongs to dog. You have the method. No, in the dog method, you have the sound method, right? So the sound method of dog class will be executed. If you confirm it is a cat, the sound method of the cat will be executed. So there will be no confusion executing these things in the real time. In the future, we will be having few more classes like something like cat, lion also maybe extends to animal. Okay, this lion has a different sound. This lion has a different sound, different future. Okay, it says something like this. Okay, you might be creating a n number of objects. If you are able to track down which object, which type it belongs to, you can execute that specific method. So that's the idea here. Right? So real-time application could be like this. Just imagine this thing. Okay? When you have something like phone pay, I've seen this example the previous one. You have something like phone pay. Okay? So you might be clicking some other things in your phone pay to check the balance. Okay, check the this Axis Bank is linked into your phone pay. So HDFC may be linked into your phone pay, and you have ICICI. Okay, some objects will be created. Okay, let us say that these are the objects. Okay, A, B. Okay, in the runtime, okay, under the Axis Bank, you will be having the balance. Okay, under HDFC Bank, you will be having the balance. Okay, under ICICI Bank, you will be having some balance. In the runtime, okay, you will create in the application, the object will be created depending upon the clicking that you are doing in the front end. You might be clicking that, hey, check the balance of Axis Bank. Okay, for that object will be created a new axis. Okay, or else you might be choosing, hey, check the balance for the HDFC Bank. Okay, or else you might be choosing. So you will be doing a click, but internally these objects will be created. Some of these objects will be created because of the code that is written by the developers. I see. Simply I am saying, okay, just okay, if the runtime the checking will happen. What kind of checking will happen? If a instance of axis, okay, execute the balance method of Axis Bank. Okay. So each and the balance method is common for all the banks. Okay. Likewise, else if a instance of ICICI, execute the balance method of ICICI Bank. Okay. Else, if these two are not there, the remaining bank is what? Remaining bank could be a default bank. Default bank in the sense that the actual bank that you are using. Anything can be a default. In this case, the default bank is going to be what? Default bank is going to be the HDFC. Execute the balance method of HDFC. In the runtime, you will be getting this kind of control. Instead of it will help to track which object that is reference to, which type it belongs to, After doing this, you have an option. Okay, this part is called. You can execute that particular method of this particular type. That control will be coming. Okay, this is the idea about instance of operator. Okay, if you ever have to give the small theory about this, the theory could be like this. So, what is an instance of operator? Instance of operator or keyword. Instance of instance of is a keyword used for checking. Is used for checking if a reference variable of an object contains given type object reference or not. It is also known as the comparison operator, which is getting compared with type. Or else you can say that the reference variable is getting compared to this type. Okay, and please be informed that it always returns true or false. True or false or exception. You have seen this. When there is no relationship, when you are making there is no relationship between classes, you try to check the instance, use the instance of operation for a different class which is not a relationship, you get an exception. Not exception, error, compile time error. Like like this. And what else we have? Syntax. Get and variable instance of operator. There should not be any spaces. Class name. Okay. It returns true or false. You know this. Example, class A. Okay. A obj equal to new A. Okay. So obj instance of. Okay. That's it. That's all about the instance of operator. By this we are able to understand the